Thank you, Luis. My name's Kolenko, and I'm Chair of Engineering and Information Technology at Conestoga College. We actually have 3 chairs of Engineering and Information Technology. My counterpart's Mitch Wozniak. He covers the mechanical engineering, robotics, energy systems, electrical engineering. Julia Biederman, she covers things like the architecture, the civil engineering, construction engineering, those sorts of areas. And for myself, I cover the software engineering, the electronics engineering, and the information technology areas that we deal with at Conestoga College. Again, Conestoga College does have an applied research area. In the back corner there is one of my colleagues, Greg Robertson. He is the director of Conestoga's Applied Research and Innovation Office, the CARI office. And CARI, as a unit of Conestoga College, again, our mission statement is to provide applied research services to businesses, industry, health, community services, and so forth, and other educational partners. We assist in furthering the research capacity of the college. So one thing that's different about Conestoga as a college here in Ontario versus University of Guelph as a university in Ontario is that our faculty are not paid to research. So we have to find ways of squeezing research into the normal teaching duties of our faculty. So we end up having faculty that get hired to teach specific subject areas, and in many cases there's just simply no time in their workload to be able to support any research. So through the appropriate funding agencies and the work that Greg does with the CARI office, we find ways to release our faculty from their regular teaching duties and then give them the opportunity to work in an applied research environment. So again, the idea behind it is that eventually the work that happens from a research perspective filters its way back into the teaching that our faculty do to our students. So again, very different model from your typical university, and again, it causes a little bit of a struggle in terms of finding the right way to make this work in the long term. Again, we try to promote a research capability and interest of the college to external partners. So again, that's the marketing side of what CARI does. Again, to be able to pull in better and higher quality applied research clients in the long term. Again, from the services perspective, we supply research support to companies who are interested in becoming involved in research. So again, we sometimes work with very small companies, people that have just ideas. They might not be able to take advantage of some of the larger scale funding opportunities for NSERC and so forth. Again, we have different ways of being able to provide research opportunities to even the smallest of companies. And as I mentioned in some of my examples, ideas such as capstone research. Our students are typically required as part of their academics to be able to do a final year or final semester project to prove their capabilities to industry. So industry gets invited down to judge these projects, and then industry can see, oh yeah, that student, they got exactly the right set of skills to be able to make a contribution to my company. So that kind of project environment, again, allows students to be able to say, hey, I'm interested in doing a project on this topic area, and then we invite industry. And again, in many cases, these are small companies that maybe are looking at skunkworks ideas that they can't afford to do internally. We have that kind of capacity to support that through our students. Again, bring services of our technically trained faculty. Again, our faculty are generally industry experts in their subject areas. Because Conestoga now, and it's not just Conestoga, but the college system in general over the last 10 years has now been able to offer applied degrees to our students, we now actually have a much greater need for PhDs to be on staff. But in the past, again, it's been traditionally industry experts that come into the college and do that kind of vocational or technical training. So again, now that we have PhDs on staff, we do have a little bit more capacity to do some of that higher level research. And again, we keep on trying to bring in new opportunities to bring in things like new state-of-the-art equipment through funding opportunities, and again, be able to increase our capacity of being able to do some of this nifty stuff in the long term. So again, just a lot of the same basic ideas that that University of Guelph presentation just covered. We do some of these same sort of things here at Conestoga College. One thing that should be noted, and again I mentioned it briefly, universities are quite often involved in that idea of basic or fundamental research, where again an idea is out there, they do the research, and whether or not that leads to commercialization in the long term isn't necessarily a driver for that research. Again, colleges are not funded to allow our faculties to perform that kind of basic research. So we depend on having an adequately funded project to allow our faculty to get the appropriate release time to then support as a principal investigator an applied research project. So we concentrate specifically on applied research and applied research only. Again, if that changes down the road in terms of the way governments fund the college system versus the university system, again, that might lead to new opportunities, but for now it's mainly applied research that we have to deal with. Again, we do have opportunities in terms of college and university collaboration. So the NSERC CU I2I research grants allow that kind of collaboration where, again, we can work with the University of Waterloo or University of Guelph and so forth on various projects. Conestoga's innovation, again, we have again, a very, very practically minded educational environment. Again, the idea behind Conestoga College and other colleges in Ontario is to provide that hands-on learning opportunity. So in my area, for example, where we do things like electronics, where we do software engineering and so forth, our students are, again, trained on the latest of technologies. Our students work with the BlackBerry Playbook. They work with the latest devices. They work with the latest electronics manufacturing techniques and so forth. And again, a lot of that is in collaboration with industry. So again, a company like RIM, for example, could then take our electronics students, give them co-op opportunities and eventually graduate opportunities where they now have exactly the skills that Research in Motion requires to perform their work on a day-to-day basis. So again, we're very, very good at that level of capability. And again, the idea behind the research projects is to continue to expand what our opportunities and capabilities are going to be. Some of the things that we, again, are trying to do with our students, and again, this is more something that's been done quite well at universities over the years versus at the college level. Our students come in typically job fixated. I'm going to take a 2-year technician or a 3-year technology diploma, and my job is to be a technologist when I graduate. So they don't really think entrepreneurially. So what we end up trying to do these days is, again, since innovation and research is now coming to the college system, we are trying to switch that mindset so that our students that are coming in are also interested in the entrepreneurial side of things. So later in my presentation I will mention, and I'll briefly mention it now, we do actually have our own Center for Innovation as well. Royal Bank had just donated $250,000 to get that off the ground. And is the Bank of Montreal, I think, involved in that as well, Greg? Yeah, so again, 2 of our larger banks here in Canada are throwing money into Conestoga to, again, begin fostering that sense of entrepreneurship in students that traditionally come just to get the training, to get the jobs. So again, very different kind of student that we get at the college, and as a result, we have a different kind of approach to how we want to do research at the college. So a couple of examples of how we support the research. As I mentioned, in some cases we actually have people, there might be a sole proprietor out there that has an idea but simply can't afford to bring an idea to market. So they come to the college on a regular basis. These could be people that need specialized web support. They could be people that need support to develop a new device and so forth. And because our students have this requirement to demonstrate their capabilities through these final year or final semester projects, we refer to those as capstone, the end of their academic career projects. And these projects, again, could be 8 months in length. So that's what electronics and software engineering do. And 4 months in length, which is the information technology side of things. And again, my counterparts in the mechanical and civil and so forth, they have their own styles of this capstone project idea. So one example that I have up on the board here was a small company in the Fergus area at the time. They came to Conestoga and said, we need some help developing a mobile application that would support the dissemination of consumer and health warnings to the public. So what happens in Canada is that Health Canada might issue a warning. There might be a weather warning that comes out. There might be a product recall warning that comes out from Industry Canada. And again, every one of these agencies that provides a warning just tosses it out there in their website. So if I'm a consumer that has to know all the dirty little secrets of what's happening out there, I end up having to go to this website, this website, this website, this website, and hopefully I understand what's going on. So they created an aggregator that could pull all those bits and pieces of knowledge together and put them all into one convenient application. So again, the company itself didn't have the resources to do that. Our students were required to be able to show competence in mobile software development, glue the two together, perfect project. And again, an opportunity for that company to get a product on the market to help show their customers that they are capable of providing this kind of software, and obviously got our students involved in terms of doing something really cool and innovative. What was neat is that the students that worked in this particular project, they actually got hired by the company afterwards because they approved it. They got that product to market. And now these same students are coming back to the college saying, here's the next project, here's the third project, and we keep that cycle going. So this is really cool because this essentially costs nothing to our industry partners. Again, if they can provide materials, so in this case the company provided some iOS devices, so Apple, the iPad, the iPhone and so forth. That was donated to the students in terms of the project. There's no other cost. Again, you didn't have to fork over $1,000, $10,000 to the college to support this research. And again, because our students do this academically, there is no need to pay the students in terms. So kind of like slave labor, but shouldn't be thought of it in that fashion. The idea is to get the students the opportunity to showcase their skills. The second example, again, is in my electronics area. We do have a 4-year degree in electronic systems engineering. And the project in this case revolves around some work with Princess Margaret Hospital and a few of our professors in terms of being able to create a mechanism, a manufacturing process to develop a mechanism to inject light into an area that has been, I guess, I wouldn't say configured, but I guess a light-sensitive drug was first injected. Now the light has to be put into the area to activate the light-sensitive drug. And the current process is this bundle of glass fibers get stuck into your skin, and it's a horrifically painful, excruciating process. And again, Princess Margaret Hospital is looking for a much more effective solution. So these students and the professor are working on a mechanism to take a very fine needle and wrap fiber optics around the needle, and in the process to deform the fiber optics to allow the greatest amount of light leakage towards the tip of the needle. And again, this actually has nothing to do with electronics. We do happen to have fiber optics support as part of the electronics environment for communications purposes. But again, our students, since they understand fiber and how it works and its properties, are able to apply that knowledge, in this case, a medical application. So a really good example of how we think outside the box, and a really cool project. And the idea here is to be able to provide a prototype to Princess Margaret in terms of their next steps down the road. We do an awful lot from the advanced manufacturing perspective. So again, as I mentioned, my counterparts in mechanical engineering, his area has had a lot of projects over the last couple of years that revolve around advanced manufacturing. So Rimowa, which is a German suitcase manufacturer, has a factory in Cambridge, and our students and faculty worked on automated manufacturing support for that organization. So again, this was actually one of our first FedDev projects. So you mentioned FedDev as one of your funding sources. Conestoga, what's in it, two rounds of FedDev? Yeah, so about $750,000 per round came to Conestoga. So again, it's some reasonable dollars coming in. And again, I think it's about 10 to 15 projects per round, I think, came out of it. Yeah, something like that. So again, not a huge amount of research, but we try to maximize what value comes out of any research dollar that comes in. And I guess something I should mention in terms of Conestoga's research, we actually, I think, lose a little bit of money on each project, but the intent is to get from a return on investment is that new knowledge that we can bring back to our students in the classroom afterwards. And fourth example, again, actually a little bit in the food processing area. Again, it was a mechanical engineering group that was looking at helping design environmentally friendly compostable packaging for a company called Catan Kitchens. So again, it was one of these things where somebody had the idea, we had the expertise in terms of building the manufacturing process to make it happen, and the result was a solution for the industry partner. Something, again, that we do quite well at the college is grassroots-oriented innovation. So for myself, as somebody in the software and electronics realm, I cover areas such as open source development. I'd spoken to somebody at my table earlier about why isn't there the equivalent of an open source in the food industry? Again, it works really well in the software industry. It reduces costs, fosters great innovation, and it's a global idea. Everybody in the world works in this environment of open source. And now we're creating our own open source center at the college. I also do challenges. Again, something that I believe heavily is that students come to the college, they do their work, they learn subject A, subject B, subject C, and in many cases, they don't realize that even after just a few subjects that they've learned, that they can actually begin to innovate. So the idea of my 4x4 challenge is in the winter semester, we have a 4-day reading break in February, and I say over those 4 days, I want to see a minimum of 4 cool things, be it mobile, be it electronics. I just want my students to do something, create something. So again, this is a low-cost opportunity. I can buy a few little devices here and there, get some mobile devices into the students in terms of mobile development. And again, give the students an opportunity to prove to not only themselves, but to the outside world that they are capable of doing something outside the box. So it actually last year was our first run, and it was very successful. We had 35 students involved, and a local company, Desire to Learn, which creates educational software that's distributed worldwide. One of their people came in to do the keynote, and as a result, there was a number of students that were actually hired directly for co-op opportunities as a result of that. So again, just another example of a different model, a different way of supporting the innovation. Again, just a couple of examples. Those are students on the left-hand side there. They did a really cool project on automated genre detection in music. So these were 4-year degree students in electronics. Audio would come in from your iPod or what have you. The system would automatically detect, oh, that's country, that's rock and roll, that's death metal, whatever the genre of music happens to be. And based on that, it would automatically equalize the music, because again, depending on the kind of music, you want treble higher, you want bass higher, and so forth. So they would automatically equalize the music based on genre. And then the third stage of their project was the visualization. So if you think about, I'm not sure if anybody here goes to clubs and so forth, but you see all those flashing lights and the pumping music and blah, blah, blah. So what they want to be able to do was to create a different mechanism for the control of that kind of environment. So they actually utilized ferrofluid, and they controlled it through magnets. And again, based on the equalization of the music and the genre detection, the ferrofluid pulsated and just created, it was really cool. We'll leave it at that. So they entered a project they entered their project at the IEEE Student Papers event at University of Waterloo, and they won first prize ahead of some robotics teams that University of Waterloo had entered into the contest. So again, it just proves that even though it's college, we can compete on the same level as universities in terms of innovation. And these two students here were actually my students. I became chair last year, so prior to that I was faculty in the software engineering technology group, and these two students of mine, I convinced them to enter. They won my 4x4 challenge. They entered then the Desire to Learn pitch night, which was sort of a Dragon's Den kind of event. They took that project that won them the 4x4, won $1,000 at the pitch night. They then continued working on the project on their spare time, and Desire to Learn had the next level of project called the Edge Challenge, and won another $11,000 in that challenge. Again, just to prove, and I proved to these students, it's like, hey, I told you you could do it, and they did. So again, just a couple of examples of some of the innovation that's possible. Again, you can read this on your own afterwards, but Conestoga's Cary office, again, has had lots of advanced manufacturing research opportunities, environmental research, health and life sciences research, and a number of outreach projects. Again, our list of projects is not huge. Again, we've only been doing this for a relatively short period of time. Again, we don't have 150 times 2 years worth of history behind us. The college system in Ontario is only a little over 40 years old to begin with. So again, it's not a lot of history, and we're playing catch up, but I think we're doing a fairly good job based on how we do it. Again, leave you with a few links. The way we promote applied research is obviously through our own websites. We are a member of Polytechnics Canada. Again, we participate in events like this where we can do some direct marketing. And again, the happier our clients are, the more they're going to talk amongst each other and hopefully bring new projects to the college down the road. The cost of services funding, et cetera. Again, Conestoga does not fund its own internal research. So again, our professors can't say, hey, I want to do a new project in this area. We can't fund that internally. We simply do not have the money to support that. So it has to be funded research or free, as the Capstone Project idea. So again, we do have similar funding sources, again, things like the FedDev, ARC, the NSERC ARD, the OCE, the CONES, and so forth. Again, Capstone Project research, again, is quite often unfunded, but because it's meant to support academic needs, again, it's an easy one to support for industry simply because students don't have to be paid. Again, they're doing this for their academics. How does Conestoga support the release of faculty? Again, Greg has developed this monstrous formula to support the cost of taking a faculty member out and replacing them with part-time faculty support so that our principal investigator faculty can work on a particular project. So there is a direct cost involved there that hopefully gets covered by funding, but there's also an indirect cost because the instant we take a faculty member that was hired to teach a particular subject area out of the classroom and bring in part-time support to replace them, it's just like regular, high school or grade school where the supply teacher just doesn't do the same kind of teaching support as the regular teacher does. So there is a cost to the students in that they now don't have access to that professor for X number of courses for X number of semesters. The benefit there in the long term is that once the professor has completed the project and comes back to the classroom, they have now got new set of skills, new opportunities that they can impart to the future generations of students that come through. So again, it's a bit of a rough issue at times. But our students recognize that this is the future, and our students love being researchers. Again, they are paid as co-op students. That's actually covered as part of the funding that Greg arranges. So again, co-op opportunities have come out. I think one of our projects in the electronics four-year degree has already, was it 6 or 7 co-op jobs already, and another, could be up to 20 altogether by the time the project is complete, I think, right? So that's a lot of paid labor that the students can take advantage of. And again, return on investment, same sort of theme. How do you measure it? I mean, we're not in the process of saying we got to make 10% or 15% or anything on these investments. Like I said earlier, we technically lose a little bit of money on every project, so that's a negative return. But the benefit again is increasing our exposure to the industry, luring better quality students in the long term to the college when they recognize that, hey, the colleges are doing research just like universities are doing, and again, hopefully letting the government recognize that if they could fund us the right way, we can do some really cool things just like universities do. Fostering innovation, again, Conestoga in many cases is really lucky because we're in the hotbed of our high-tech industry. Again, companies like Research in Motion and Google is in Waterloo region. These are big name brand companies that are in the area, so it's sort of a mini Silicon Valley. And again, Kitchener-Waterloo also had a large and tremendous history in manufacturing. So that whole idea of advanced manufacturing still is very, very relevant to our area. So again, we're in a great area to be doing this. We hire faculty that are very adept at being able to not only teach, but also to work with industry, because they're hired directly out of industry in many cases. As I mentioned earlier, we do now have a Center for Entrepreneurship, so student entrepreneurs that have their ideas, they could be doing, again, their regular classroom work, they can take classes on how to be an entrepreneur and be able to then get the appropriate access to angel investors and so forth to take their ideas to market. And again, we work closely with incubators like Communitech, the Innovation Center up in Waterloo and so forth. So again, we do have those partnerships that we rely upon on a regular basis. The role of training and education, so same sort of theme as you had earlier. Again, students that are exposed to entrepreneurship, that are exposed to research, generally begin to think out of the box. They become the thinkers that we hope will create wealth in the long term. And that's something that, again, as myself, I was a consultant in the software industry for many years. I ran my own consulting company. And for me, creating value is what it's all about. Creating, again, future wealth is what it's all about. So again, I want my students in my area to have that same kind of mentality. I don't want people coming and saying, give me a job. No, I want you to create the jobs. Maybe you'll hire the next level of student coming through in the long term. So again, that's the kind of thinking I want students to start picking up. And yeah, that pretty much is it. So that's my presentation. Thanks for listening.